Welcome to Season 2 of Let's Talk About Electric Vehicles. My name is Teresa. I'm an economist living in Canada. And what can I say? I'm just passionate about electric transportation. And moreover, I want to find answers to more general questions like how to deal with used batteries or how to stabilize and prepare the electricity grid for more electric vehicles. And what I do is I try to find answers to these questions in academic research. This week's episode, I want to talk a little bit about electrified urban buses. The electrification of urban buses seems to happen faster than the electrification of passenger cars. And since my Twitter feed has lately been full of announcements of new electric public buses in various Canadian cities, I thought I'd have a closer look at what academia says about the performance of these buses. And there's no better place to look at when it comes to urban buses than China, which is the world leader of the global electric bus market, especially when it comes to fully electric vehicles. China has a long history of government incentives for electric urban buses to achieve a better air quality inside the cities. But the actual performance of battery electric buses is still a bit unclear. The performance in form of electricity consumption and driving range has been tested under laboratory conditions multiple times, but there's only very few studies that look at the performance under real-world conditions, namely congested streets, heavy loads, and with air conditioning running. So therefore, today I present to you the findings of one practical study from the Chinese city Macao. I think we can all agree that electric buses make the urban air quality better since they do not have any tailpipe emissions, whereas diesel buses, for example, they emit plentiful, harmful emissions that get stuck between the buildings inside the city. Electric buses don't have these tailpipe emissions, but the crucial question is, do they pollute in any other ways? It takes a lot of electricity to accelerate a fully loaded bus, especially if the traffic is congested and the bus has to stop and go frequently. And therefore, the electric motor needs a lot of energy in order to keep the bus running. So, should the electric bus be too energy inefficient, we would have a cleaner air inside the city, yes, but at the same time, we would pollute the planet through unnecessarily high electricity consumption. Especially in areas with higher fossil energy generation, this practice only shifts the burden from one area to another. He and others from 2018, these are Chinese researchers, they wanted to know how energy efficient the two oldest operating electric public bus models in Macao really are. They criticize that it is not accurate to estimate the energy consumption through laboratory tests only, where buses usually drive a steady pace. These laboratory experiments can be helpful as a first point of orientation, but they are not very realistic as they do not account for frequent stopping in congested streets, they don't account for air conditioning running, or for heavy loads in rush hours. Therefore, the authors of that study used two common electric buses and installed some tracking instruments on the vehicle to measure the current and the voltage of the battery. They also measured the motor rotation rates, the vehicle speeds, and real-time location. The data was collected second by second, so a lot of data. The authors wanted to know the bus's performance in different scenarios, when it's empty and when it's half loaded, with and without AC running. They wanted to know the bus's performance for different traffic conditions, different road types, etc., etc. Because of their detailed measurement method, they could filter the exact energy consumption in every type of movement, in brake, in idle, and in 16 different types of acceleration. But before we jump right away to the results, a few more details about the bus models. So one of the buses is 10.5 meters long, the other one is 12 meters long. They were the first two operating electric shuttle buses in Macao. Both are equipped with an iron phosphate-based lithium-ion battery pack, and the battery is fully charged within 5 hours. They used two different testing routes for the experiment. One of them went through downtown Macao with congested traffic. The other route went through the neighborhoods in the north and included less frequent stop-and-go situations, whereas the maximum speed is always 50 kilometers per hour, which is approximately 30 miles per hour. For the experiment, they hired local professional drivers and asked them to follow their regular driving behavior that they would usually have with conventional diesel buses. The experiment vehicles stopped approximately 1 minute at each bus station to simulate passengers getting on and off the bus. To simulate the weight of the passengers, the researchers used water canisters. Both test buses had tracking instrument installed on board, and then they took a bunch of rides on the test routes. Testing out different loading conditions, different traffic conditions, rush hour versus non-rush hours, and also turning on and off the air conditioning to measure the difference. And before every test ride, the battery was fully charged at 100%. And the cumulative distance of the test rides was almost 900 kilometers per vehicle. Okay, now that the experiment setup is clear, let's find out what the actual electricity consumption of these buses is and what that means for the CO2 emissions. Can electric buses really outperform the good old diesel buses, or do they just shift the pollution to a different area? Remember, the tracking instruments could measure the exact energy consumption rate for every second. So depending on whether the vehicle is in idle, is accelerating, or is braking, the consumption rate at in this particular second will be respectively low or high. The regenerative braking systems of the buses made it possible to even have a negative energy consumption rate in moments of braking. Therefore, the vehicles indeed gain energy back in moments of deceleration. Therefore, electric urban buses have a relative advantage in comparison to conventional diesel buses in congested traffic. The results show that a lower average speed and running air conditioning significantly drive up the energy consumption of electric buses. The difference between the best case scenario and the worst case scenario is 160%. Therefore, the actual driving range of the bus significantly decreases under these conditions. The findings under practical conditions are different to the results of laboratory tests, where the vehicles traditionally are tested under a steady speed of 40 kilometers per hour. The resulting energy consumption is between 1.7 and 1.4 kilowatt hours per kilometers for the 12-meter bus, and between 1.2 kilowatt hours and 2.9 kilowatt hours for the 10-meter bus. The actual driving range is 42 to 99 kilometers for the 12-meter bus and 66 to 160 kilometers for the 10-meter bus. All of these numbers are significantly shorter than the estimates from the laboratory tests. An important thing to mention here is that the average temperature of Macao is between 15 and 29 degrees Celsius, which is considered as very favorable for the battery performance. Now that we know that the energy consumption is actually much higher than what the manufacturer's test results suggest, the question is, what are the actual overall emissions that urban electric buses cause through high energy consumption? And are their emissions actually lower than those of diesel buses? You can probably guess the answer. It depends on the electricity source. Macao has a relatively high share of renewable energy generation. Therefore, the calculations of the researchers show that both electric bus models produce less CO2 emissions than conventional diesel buses of the same size, and that accounts for all operating conditions. The lower the average speed, the higher the relative advantage of electric buses. So, in congested urban traffic conditions, the electric bus produces clearly less CO2 than the diesel bus, even with running air conditioning. The situation is a bit different for bus routes that include more highways and less stop-and-go situations. The higher the average speed of the routes, the smaller the relative advantage of electric buses. The energy efficiency of diesel buses is more sensitive to traffic conditions, whereas the performance of electric buses is a bit more stable regardless whether the traffic is congested or not. These are the results of the real-life performance assessment of electric buses in Macao in China. So what can we learn from it? First of all, the actual real-life energy consumption of electric buses is higher than the results from laboratory tests due to congested traffic, heavy loads, and air conditioning. Therefore, the actual driving range is smaller than expected. In China, the typical daily range of transit buses is at least 130 kilometers. If the electric bus cannot cover this with one charge, then the whole concept of overnight charging might not be sufficient. This is a conflict between two forces. Because of the lower fuel cost, electric urban buses become relatively cheaper the higher the daily mileage. So, a limited daily driving range prevents the electric bus from seizing its full economic potential. Therefore, it needs a strategy to enhance the daily driving range of electric urban buses. The next thing that comes with higher energy consumption rates of electric buses is the question of CO2 emissions through using electricity that might come from fossil electricity generation. In Macao, where the share of renewables is relatively high, the electric bus produces less CO2 emissions than a comparable diesel bus. This calculation looks totally different in areas with higher fossil energy shares. Therefore, by enhancing the urban air quality, urban buses might shift the environmental burden just to a different area. Is this a reason to give up on electric buses? I want all of you to think about that question on your own, a little homework, so to say. I'm also more than happy to read your opinion in the comments or in my emails or at the forum on electricvehiclepodcast.com. My personal approach is the following. What is the alternative? Even without electrified transport, the demand for electricity is rising. We have to implement renewable energy generation anyways. We are currently facing a dramatic climate crisis, and the crisis is real and it affects each and every one of us. Electric buses might not reduce the overall CO2 emissions at the current electricity mix, but at least it has the potential to do so, whereas the potential of diesel buses is already fully exhausted. Diesel buses offer no room for improvement. Electric buses might not be the remedy for our planet. The best solution for the climate crisis might look completely different, but we have to keep on searching for alternatives. The worst thing we can do is keeping the status quo. The worst thing that we can do is leaning back and being satisfied with diesel buses, because I think that we deserve better. With that being said, well, I'm excited to hear what you think. We have reached the end of this episode. I hope that I could teach you something new today. You will, as always, find all of my references and contact information in the show notes. Please don't hesitate to reach out to me for feedback or topic suggestions. Have a wonderful week, and let's talk about electric vehicles again next Monday. Bye!